Hello students, in previous lecture we have studied about the rational numbers and properties of rational numbers as well as addition, subtraction, multiplication of rational numbers. Then today we are going to study about the few other numbers which are not the rational numbers, and all of you studied about that real number is a set of rational number and the numbers which are not the rational numbers. First of all, we have to remind that rational numbers which are written in the form of P and Q, whereas P and Q are integers. P and Q are integers and Q should not be 0. Therefore, that numbers are known as rational numbers. That means we can write any rational number in P upon Q form. Then those rational numbers we can also write in their decimal form. Then for example, see here 3 upon 2, it is written in the form of 1.5. Then see here the 1.5 is a decimal form of 3 upon 2. As well as there are few rational numbers that is in decimal form. I have discussed about that in previous lecture. For example, see here 0.513, 513 dot dot, that means here 0.513, that number get repeated. As well as the numbers, see here 2.3333, that means that number is written in the form of 2.3 dot, or bar line is used on the 3. Then see here rational numbers we can write in the form of P upon Q, as well as the decimal form of rational numbers is of it is in terminating type, or it may be non-terminating and recurring type. That means for example 1.5, 3.7, these are the decimal form of rational numbers which having terminating type decimal form. As well as here 2.3333, that is non-terminating recurring type of the decimal form of given rational numbers. As well as 0.513, that is bar line is used on the number 513, that is that rational number is also of non-terminating and recurring type form. That means the number which is represented in the form of P upon Q as well as their decimal forms are terminating type and non-terminating recurring type. Those numbers are rational numbers. But see here, there are few numbers of which their decimal forms are non-terminating and non-recurring also. For example, see here, if the value of root 2 is written in its decimal form, then it is 1.41, 421 and so on, that is dash dash dash. That means here the value of root 2 is 1.41, 421 and so on. Here in the decimal form of that value of root 2 is non-terminating as well as and non-recurring type of decimal form of that number. As well as value of root 3 is 1.7305080757. That means dot dot dot. That means it is also of non-terminating and non-recurring type. As well as we can write the value of root 5, that is 2.236067975. See here, decimal form of that root 5 is also of non-terminating and non-recurring. That means it is also of non-terminating, non-recurring type. We can take the few examples of that type of numbers, that is root 7, which having the value, the decimal form of root 7 is 2.64575131106. See here, it is also of non-terminating, non-recurring type decimal form of that root 7. As well as root 10, which having the value 3.162277666017. That means here the value of those numbers in their decimal form are non-terminating and non-recurring type. Then the numbers which having terminating type decimal form as well as non-terminating and recurring type decimal form, those numbers are rational numbers. But the numbers of which decimal form is non-terminating, non-recurring type, that numbers are known as irrational numbers. That numbers are known as irrational numbers. Then today we are going to discussing about the irrational numbers and their properties and the concepts which is related with the irrational numbers. All of you have studied the irrational numbers and rational numbers together called as real numbers. That means real numbers is a set of all rational numbers and all irrational numbers. Then today we are going to discussing about the irrational numbers. Then see here, all of you have studied before that the value of pi. Pi, that is the one of the irrational number. The value of pi is given by the great mathematician, that is Aryabhat, in 499 before Christ years. Aryabhat has calculated the value of pi, that is about 62,832 upon 20,000. This value which is calculated, then that value of pi we get in the decimal form, that is pi is equals to, that is 3.1415925359 dot dot dot. That means value of that pi we get in decimal form, which is also non-terminating and non-recurring type. Therefore, pi value is also irrational number, and that is given by, that is discovered by great mathematician Aryabhat. Then similarly we can calculate the values of that root 2, root 3, root 5, root 7 in their decimal form. See here, all of you have studied the method of getting roots of that natural numbers. That is division method of getting roots of natural numbers. Similarly, see here, root 2 we get the value in decimal form, that is 1.4142135627 dot dot dot. Then if we find out the value of square root of 2 by division method, then we get this value, that is decimal form of root 2. All of you studied that method in 8th standard, how to get the square root of given natural numbers. Then we have to find out the square root of 2. Then see here, first of all we have to write that 2 in non-terminating and recurring decimal form. Then see here, all of you have studied 2 is written in the form of 2.0000 many times. Then we have to make the set of 2 digits after decimal point, as well as we have to make the set of 2 digits before that decimal number. Then first of all we have to take that 2 digit set before that decimal number, that is here 2. Then we have to write or remind the squares of the natural numbers, that is 1 square 1, 2 square 4, square of 3 9, square of 4 14, square of 5 25, square of 6 36, square of 7 49, square of 8 64, square of 9 81, square of 10 100. Then see here, we have to find out the square of 1 is 1, which is less than 2, and if square of 2 is 4, which is greater than 2, therefore we have to write here 1. We have to write that 1 number in the quotient also, and we have to add the same number in it. Then we get here 1 plus 1 2, as well as multiplication of those number which is written here, that is 1 into 1 1, and we have to subtract that number from that 2, therefore we get 1 here. Then take the next 2 digit set here, that is 0 0 is taken here, which is after decimal point, therefore we have to write decimal point here. Then 100 is there. If we put 0 here, then we get 20 into 0 0, therefore putting 1, then we get 21 into 1 21, which is less than the 100. Taking 2, then see here 22 into 2 44, which is much less than the 100, therefore we have to take, that is 3. Then 23 into 3, that is 69, which is also much less than 100, therefore we have to put here 4, and therefore we get here, that is 24 into 4, that is 96, which is nearer to the 100. If we putting the value here, that is digit 5, then we get 125, which is greater than 100, which exceeds the 100, therefore here we get the value, that is 4, and therefore 24 plus 4, and that 4 is also written here, and 24 into 4, that is 96, which is subtracted from 100, and here we have to do the addition of 24 plus 4, the same digit we have to write here, for addition. Therefore, we get here 28. And here 100 minus 96, we get 4. And the division takes place here by 4. Therefore, it is written in quotient. Similarly, we took the next 2-digit number set here. Similarly, we have to take the proper number here. Take 1 here, then here 281. We get the value which is less than 400. But if we take here 2, then we get the number that is which exceeds, which is more than 400. That means here 564 we get here, which is greater than 400. Then therefore we have to take here 1, and therefore we have to write 1 in the quotient also, and then we get 281, which is subtracted from 400. Then we get the summation, that is 282. Then subtraction of 281 from 400, we get here 119. The same process we can do further by taking 2 zeros here. Then now here the numbers becomes complicated, and therefore we can do one method for it. First of all, see here only 2 is taken here, and here 2-digit number 11 is taken here. Then count the table of 2 up to the 11. That is 2 5s are 10 and 2 6s are 12, which is greater than 11. Therefore here 2 5s are 10, which is less than 11. Therefore first of all we have to write 5 here. But if we put the number 5, then we get the multiplication of that 2 8 25 into 5. See here 5 5s are 25, carry 2. 5 2s are 10 plus 2 12, carry 1. 5 8s are 40 plus 1 41, carry 4. 5 2s are 10 plus 14. See here, if we put the value that is digit 5 here, then we get 14,125, which is greater than 11,900. Therefore, instead of 5, we have to put here 4. Then we have to calculate again here. See here, 4 into 4, 60, carry 1. 4 into 2, 8, 1, 9. 4 8s are 32, that is 2, carry 3. And 4 2s are 8. 8 plus 3, that is 11. And that 11,296, which is less than 11,900. Therefore, 11,296 is written here. And therefore, the proper number before 282 is 4. Therefore, that 4 is written here also. And here we have to do the addition. 8, 2, 8, 2. And here the subtraction, we get that 4, 0, here 6. That means 604. Then again we have to take the next 2-digit number, that is 00. And similarly we can calculate the square root of that 2. Then see here, after that 4, if we put the value that is digit 1 here, then we get the value that is 28,281 here. But see here, which is much less than that 60,400. Therefore, we have to put the value 2 here, and then we have to calculate here. See here, 2 into 2, 4. 2 into 8, 16, carry 1. 2 2s are 4 and 1, 5. 2 8s are 16, carry 1. 2 2s are 5 and 1. That is 56,564, which is nearer to the 60,400. Therefore, the proper number is 2. Therefore, we have to write here 2. Then we get the value here, that is 2248282. And then we have to subtract that number from 60,400. Then we get here 3836 here. Then similarly, we can, if take the 2 zeros here again, then the next number in the quotient we get here 1, because if we put the digit 2 here, then we get the number which is greater than this number. Therefore, we have to put the value 1, that is digit 1 here, and we get the value, that is 282841. And here we get the values, that is 282842 here, and 1 is written here. Similarly, we can do this calculation and we can get the decimal form of that square root of 2. And here, see here, that process cannot be stopped here. Therefore, square root of 2 is 1.41421, and after that we get the digits, numbers, which this process cannot be stopped here. That means the decimal form of square root of 2 is non-terminating and non-recurring also. No any digit or no any set of number get repeated here. Therefore, this value of root 2 is an irrational number. Then you can get the values of square root of 3, square root of 7 using this division method. Try to get the decimal form of root 3, root 5, root 7, root 10 also by using this division method. Then the next concept, that is root 2 is irrational number, and that proof is given by indirect method. That proof cannot be given by direct method. Therefore, we have to prove that root 2 is irrational number, and that proof is given by indirect method. Indirect method. I have already discussed about that. Proof of that properties cannot be given by direct method. Therefore, we used the indirect method to prove those properties. Similarly, root 2 is irrational number. For this property, for this theorem, we use the indirect method. We can't give the proof for this property direct method. Therefore, see here we use the indirect method to prove that root 2 is an irrational number. I have already discussed about that. In indirect method, the property which we have to prove, when we give the proof of those properties by indirect method, we have to consider the opposite statement of that property. Here property is root 2 is irrational number. Therefore, first of all, in the proof, we have to consider, let us consider root 2 is a rational number. Rational number. Then that root 2 is, if it is a rational number, then root 2 can be written in the form of P upon Q. And see here, P upon Q is the simplest form of root 2. Therefore, here P is an integer as well as Q is also an integer, but Q is not equals to 0. And here, as P and Q are integers, Therefore, here factors of P is 1 and P only, as well as here factors of Q is also 1 and Q also. That is the statement number 1. Let this consider statement number 1. Then see here, as root 2 is equals to P upon Q. Therefore, see here, root 2 is equals to P upon Q. Taking squares on both sides. Therefore, we get 2 is equals to P square upon Q square. Therefore, we get Q square is equals to 2P square. Then see here, the value of Q square is 2P square. That means here Q square is the multiple of 2. That means value of Q square is 2 into P square. That means factor of Q is 2 also, because here value of Q square is 2 into P square. Therefore, factor of Q is 2, and therefore Q square is even number. Therefore, Q is also even number. Factor of Q is 2 and Q square or Q is even number. That is the second statement. Then let us consider Q is that factor of Q is 2. Therefore, that Q is a multiple of X number by 2. Then Q is equals to 2x. Therefore, Q square is equals to 4x square. But we know that Q square is 2P square. Q square is 2P square. Therefore, here 2P square is equals to 4x square. And therefore, here P square is equals to 4x square upon 2. Therefore, here P square is equals to 2x square. Then again see here, P square value is also multiple of that 2. Here 2 into x square means here the factor of P square is also 2. Therefore, P square is even number. P square is even number, as well as P is even number. And that is the statement 3rd. Then see here, from statement 1, statement 2 and statement 3, see here P and Q both are even numbers. P and Q are even numbers. But statement 1, see here, statement 1, that is factors of P and Q is only 1 and P. Here factor of P and Q is not the 2, isn't it? Therefore, these 3 statements are contradictory. Therefore, here these 3 statements becomes contradictory because we consider that square root of 2 is rational number. Root 2 is rational number. Therefore, we get 3 contradictory statements. Therefore, we have to consider that root 2 is irrational number. Then that is the proof of that irrational numbers. Similarly, we can give the proof of root 3 is an irrational number, or root 5 is also irrational numbers. One more irrational number is there. That is, we can give the proof of that number 2 plus root 3, which is also irrational number. Irrational number. Then the proof of this statement is also given by indirect method. Therefore, let us consider 2 plus root 3 is not an irrational number. Irrational number. That means here 2 plus root 3 is a rational number. If it is not an irrational number, then it is a rational number. Therefore, 2 plus root 3 is written in the form of P upon Q. As we write 2 plus root 3 in P upon Q form, then we can get the next equation, that is here P upon Q is equals to 2 plus root 3. Therefore, see here P upon Q, that 2 is taken here, minus 2 is equals to root 3. Then see here P upon Q is that number is a rational number. Minus 2 is also rational number. Then here, as P upon Q is a rational number and 2 is also a rational number, therefore P upon Q minus 2 is also rational number. Here LHS, that is P upon Q minus 2, LHS is a rational number. And here right hand side, see here, all of you have studied that root 3 is irrational number. Therefore here RHS is irrational number. Irrational number. That means here we get the left hand side and right hand side. Left hand side number is rational number, which is equals to the value of that root 3, which is irrational number, and that we get contradictory. That means here LHS is not equals to RHS. This statement is here we get because we consider that 2 plus root 3 is not an irrational number. Therefore here 2 plus root 3 is an irrational number. Irrational number. Similar type of proof we can give for irrational numbers. Then these type of examples which is given in the practice set 2.2, you may solve the practice set 2.2 and try to solve the examples from it. Then in next lecture we will discuss about that how to represent those irrational numbers on number line. There are infinite points on number lines, and every point on number line which is related with the real number, that means on number line we can represent the irrational numbers also, and that we will see in next lecture. Thank you.